Hello, YouTube. Starting the live stream. If you're seeing this, you're probably watching after the live stream. I don't think anyone even sees it yet. Let's go to this instead. And I don't see my. Oh, there we go. Sorry, just getting chat. I can see chat and do the thing at the same time. Oh, I didn't hear that. Might be a problem. It should be good. Hello. Hope that everybody's doing well. It's what day is it? Tuesday. And we're going to be doing some geometry. I think I'm artificially increasing the viewer count, but that's just so that I can create an endless loop and put some stuff in the chat. Oh, you all right? Got the puppy. Puppy's getting bigger. She's not lick me. Hey. And in a second, we'll do some math. Probably. I think we're getting fewer and fewer people showing up, which is unsurprising to say the least. I also didn't send a reminder, which I should do that. I think I'm the only one watching myself right now. Oh, I really wish I had a good way. Yes. Well, if I don't get anyone, oh, hi, my. We got one. I wonder if my chat's on. Videos both watching. Watch. You missed the puppy. You missed the puppy. Just a second. Yeah, my keyboard is very quiet. No, I have not. All right, so there we go. Now I have stream the chat. Okay. Hope you're doing all right. We're going to start with some review, which means I need to remember what the review problems were. 614. Oh, I don't think I have to page. Sorry for the delay. Hey, Giovanna. Hi, Elijah. And, oh, Monique. Hello. I really encourage you guys. I've noticed this. I'll talk really quick before I get to problems. I've really noticed that the geometry classes, surprisingly, have a harder time communicating with chat than my algebra classes. I think some of that has to do with just like the age difference and the relationship there. The juniors know each other and have known each other for long. But it's really hard for me to talk to a blank wall. I'm not used to it. So it is super helpful for me to get feedback and for you guys to talk in the chat. Super helpful. Even though sometimes it distracts me, whatever it is, it's really helpful. So yeah, if you could do that, that'd be great. And we're gonna do some things. I didn't prep a Kahoot, but I'm pretty sure that we could do a Kahoot on here. So we might do that on Thursday. Okay, so first things, remember you can turn in late work to Remind or my email. I should be mostly caught up on those things. I've had a few people turn stuff in that I haven't graded yet. That was like from this weekend. Right? Okay, so I've turned in. I've graded most of our stuff. I haven't checked my turn-in email, so if you turned in a project that way, I haven't checked that recently. But grades are basically I think they're mostly up to date, especially for geometry. So if you want to turn stuff in, you should email it to me or send it to me on Remind. Also, remember, I sent you emails, which means you probably, if you know about the YouTube thing and you're here, then you already know about this. But there's a Dropbox folder that has useful files in it. I put in the student journal pages for today, so those might be useful. The work I assign is also for extra credit that can raise our grades. No, not all of it. No. Maybe some of it. But most people haven't been sending it to me, so how would I know if you did it or not? But yeah, that's just extra practice. I may have some things that are extra credit, like we're going to get to the end of chapter 11, and I'll have something for extra credit for that. But mostly you should just do the things that you need to do to that we're already due. That's extra credit, right? Turning that stuff in is extra credit. Turn stuff in. Oh yeah, Dropbox folder has stuff in it. Useful things, chapter summary, student journal, those kind of things. I will probably try and do a Kahoot on Thursday, I think. I might try something new today. We'll see if I can get the straw poll working. We'll see about that. Oh, I should have closed that. That's why I love it. What are you talking about? Okay. I'd like to get some feedback, so we're going to go over some things, and 7 of us that are here, I'm going to ask you answers to questions. So we'll get there when we get there. First thing, we're going to go over old problems. If you use textbook for the study guide. When you're making a study guide, Monique? When you're making a study guide, you can use anything, but you have to come up with your own problem, right? So don't just copy problems from somewhere. But the textbook chapter is the things that we covered for that chapter, so it would be helpful to look at the chapter summary or the chapter sections in the chapter and kind of go over what kinds of information was in there. Now that I don't know what chapter, we have to be more clear. Sorry. There's an annoying delay, and I haven't figured out how to fix that yet. So Get back to me. Let me know what you're actually thinking. No, you cannot retake an assessment without doing a study guide. The way that I want you to do it is you make the study guide and you do the test on Khan Academy. So you have to do both. You have to do both of those things together. There's the retake. Okay, so on mine, I said the practice problems were 3 through 10, 19 shades. Okay, so this is the practice problems. This is 614, I think. Yep. So we said 3 through 10. 3 through 10 is find the area, and we had a formula to do that. Yeah, find a bunch of measures. And then 19 through 22 was these. It was find the area by finding the triangles and then multiplying. Okay. Yep. So to do that, yeah, let's start with 3. The formula, but I'm going to open the other section. The formula in it. Let's see, 11 point. Alright, so here's our student journal. Yeah, these two formulas, we have this formula. So area is 1/2 times the diameter times the other diameter. Yes, Giovanni, you have to send the study guide to me. Yeah, so you also need to tell me that you took the test on Khan Academy, and I may need you to help me with that by sending me a screenshot of your results, because I think unless I assign it to you, which I'm not going to assign everyone the tests, I don't get the results. So once you've taken it, you have to show me the results. But so far I've had no one try, so no problem. But yeah, we'll have to do some work there. So our formula, if we're here, is 1/2 diameter times diameter. So 1/2 d1 is the area. Right? Diagonal. Okay. So our problems were, I got 2 names of these. Okay, so that first one, we have 19 and 38. So we would just multiply. I'm not going to do all these because these are pretty simple. 3 here would be 1/2, 19, and 38. No, 38. And then we plug that in a calculator. It's 19 times half of 38. It's 19 squared. Okay. So using that formula is pretty simple. The other one that I want to do is we'll do number 6, but we'll do number 5 first. So number 5, we would do 1/2, and then we have to multiply the total diagonal length. So it's not 5, right? It's 10. And then it's not 7, it's 14. So we get this one. 1/2 times 10 times 14. And this we can just divide the 14 by 2. That will give us 10 times 7, which is 7. Okay, and then I also want to do 6, because 6 is a bit annoying. So we took the one diagonal and the other diagonal and multiplied them and divided by 2. 140 divided by 2, or 14 divided by 2 is something. Okay, and then number 6 has one of the side lengths, right? So this is a bit, I'll draw it. This is 5. These are the same. This is a rhombus. These are all the same. And then this value is 6. Which means half of it is 3. And we need that half to find this length here. We need to find this height. And the way we're going to do that is we're going to use this 5, and this is 3 because the total length is 6, so we do 3 squared plus x squared equals 5 squared. And it's a... Oh, I have the thing backwards. This should be 3 and this should be 3. The height is 6, sorry. But it's going to be the same. So 3 squared plus 4 squared equals 5 squared. 4. You don't know how to say God, my clever is. They're really not letting you in? Oh, that's really... Shit. You have to pick the right school district. I think that might be an issue. Maybe I'll show you how I highlight later. And then, where was I? Oh, right, so this is 4. So it's an 8 and a 6 and half of that. So it's there. Okay. That's number 6. Oh. Okay. So the height here, I drew it angled. This is 6, right? So each half is 3. And then we need to find this length so we can find the total length here. This is 4, because it's a 3, 4, 5 right triangle. And then this is also 4. So it's an 8 and a 6 is the diagonals. And half that gives us. Yeah. Okay. So those are using that formula. Okay, the other ones on here, 19 and 20, 19 through 22, are we need to use the apothem in that formula. So that's a different formula, which was, here's our student journal. The formula is this. So the area is 1/2 of the apothem times, I don't really want to use the perimeter, times the sides, times the number of sides. The number of triangles. Okay. Maybe after I'm done with this review, then I will do an example. Okay, so this is our formula. And our problems were these ones. Okay. I'm not going to do actually 19 is really easy. So 19 is the area is 1/2 times 2 square root 3. Okay, good. Well, I might do it anyway just because other people have an issue. Okay. So 1/2 2 root 3 times the side value, which is 12, times the number of sides, which is 3. So sides of 12. Number of sides, there's 3 sides to this triangle right here, and then the apothem was the 2 root 3. So we got like this, and then we would just simplify stuff. And you could put this in your calculator to get a decimal from the root 3, but you could also just do 12 times 3 is 36. Okay, and then this is some decimal, right? Whatever it is. Okay, that's the easiest one because it's got just all the values. The other ones you need to do some calculations, and you're going to do that by either using the fact that it's a right triangle or using the angles or any of those sorts of things. So you're going to want to calculate. 20. We have I'm just going to redraw the triangle. This is 10. This is right angle. This is 6.84, which means that this is half of that, so it's 3.42. Okay, so then we'd use Pythagorean theorem. 10 squared equals 3.42 squared plus x squared. This is x. Awesome. And we'd subtract squared minus 2 squared and take the square root, so that equals x. I'm not switching back and forth on the screens fast enough. So we, for 20, we took the 10. This is 6.48, it's the side, and half of that is this piece of the rectangle. And then to find the x value here, we're going to use Pythagorean theorem. You could not use Pythagorean theorem. You could use the number of angles, the value of the angles, divided by 360 type thing, to find the angle, and you can use sine, cosine, tangent. I figured this would be faster. Might not be. Okay, so Desmos 2 times. So we have the square root of 10 squared minus 3.42 squared, and that gives us 9 point whatever that is. So x is 9.3969. Okay, and so we're going to use that value to find the rest of the area using the formula up here. Okay, so it's 1/2. The apothem is this number. Times the side length, which was 6.84. They gave us that. That's this thing. And then we need the number of sides. So how many sides did our shape have? If we go back to back to the book, like this, it's got 1, 2, 3, 4, 5, 6, 7, 8, 9. We'll check 1, 2, 3, 4, 5, 6, 7, 8, 9. So then I would use a calculator to calculate that. This thing. So in Desmos, we would do, I would leave this weird decimal, and I would do 0.5 times that thing. And then I would, sorry, like this. And so half of that times 6.84 times 9. So that gives us an area of 289.23. And we would be using the calculators to do this normally. Okay. So that would be the area. Now, do I want to do any of the rest of these? 21 is basically the same thing. 22 just tells me 7. You right, Doggy? We'll do 22. Just, I think today's, this is a review from what we did last week, but today's like lessoning thing, I think is kind of easy. Alright, so 22. 22 looks like this. It's a hexagon. It's a regular hexagon. These are 7. That's not a very regular looking hexagon. And we need to find the area of this one triangle. We need to find the height. Another base is 7. We need to find the height. Now, to do that, we have there's a fair number of ways, but we're going to use the fact that we can find this angle by splitting this thing up into pieces. So this thing at 1, 2, 3, 4, 5, 6. So each of those is going to be 60. And half of that is 30 is our degrees. So to find this height right here, this is 3.5, we would do tangent, opposite over adjacent, right? Tan of 30 equals 3.5 over the height. And then we would do h equals 30. 3.5 divided by 2. Right, so then we go to calculator. 3.5 divided by 10. Wait a minute. Oh, Desmos is in radians. That would do it. We gotta be in degrees. There we go. That seems great. So H is 6.26. Okay. Yeah. So gotta be in degrees. That's not the answer. That's just the height. So 1/2 the area is going to be a half of the Potham, that number, 6.06 going on, times the side value, which was 7, times the number of sides, which was 6. So I would just do this in a calculator. So 0.5 times that, times 7 times the 6. So the area is 1.7. Okay, so that's review. That took longer than I thought, but that's fine. Okay, so that was how to do 1 2. Okay. So today, this is what I did. This right here. Okay. Yeah, so we're finding the areas of triangles, and we're applying it to a bigger shape. Yeah. So we're going to move on to the next thing we're doing today. The thing we're doing today in the chapter summary is looking at shapes. It's not really listed here. Huh. Well, that's weird. We're going to be looking at 3D shapes. So we're going to start looking at 3D solids. So this kind of thing. This kind of thing. So 3-dimensional solids. Okay. Now we have a couple of important pieces of information. So if you're in your textbook, I'm going to be in page 617. Where this is? Page 617. And when you have a 3-dimensional shape, there's 3 different pieces of information about that shape. It's got vertexes, which are the corners, the points. It's got edges, which are the lines that make up the sides. And then it's got faces. Okay. So let me grab a box. This is a board game. Right? Switch to this screen. This is a board game. All right, we have edges on the box. There's an edge. There's an edge. Edge. Faces. Faces can be different sizes. So we have the front face, right? And then we have the side faces. And the vertices make up the points, so they're the corners. So we have a face, right? Vertices, and then all the edges are the things that make up like right angles. Okay. So this is a prism, right? If you think of it as a whole shape, it's not really because you open it up and it's hollow and all that kind of stuff. But it's prism. Anything cylindrical? This candle, right? It's a cylinder. It's got an edge at the top here. This is the edge, and then it's got kind of faces. This is a face. The top is a face. The bottom is a face. It only has 3 faces, and it has no vertices. Right? The edges don't meet and point because it's open up top, really. But if this was flat, it doesn't have any vertices. It just has edges. Okay. So when we go back to our textbook, what we would do in class normally is we would look at the different types and we'd name them. So tetrahedrons, it's triangles that make up the faces. A cube, we have rectangles or squares that make up the faces. Octahedron has, it's based on the number of sides. Octa is 8 sides. Tetra being 4. So this is a 4-sided shape. 1, 2, 3, 4 faces. Remember the dotted lines go behind. Okay, and then octahedron has 8 sides. And I would have brought isosahedron is 20-sided shape. Dodecahedron is 12. In class, I would have brought a bunch of dice and would have looked at all these things. They make dice that are these shapes. Okay. So they're platonic solids. This is because the faces are identical. So this tetrahedron has triangles. They're all the same size triangles. This cube, all the squares are the same size. This octahedron, all these triangles are the same size triangle. All these triangles in this isosahedron are the same. All these pentagons are the same size. Okay. So the platonic solids, there's only 5 of them. They're special because all the faces are exactly the same size. Okay. And then the other thing that we're going to do this chapter, so here's our types. It's made up of polygons. It's a polyhedron. Okay. Now, the other thing, I'm not really super worried about the naming. Not super worried about that. What I do want you to understand is this cross section. If we were to take a piece of paper and make it super thin so that it could go through the atoms of space, that paper could pass through something, and we're worried about what the shape of the intersection is. Okay, so when we take a cross section, when we take a slice of our shape, what kind of shape do we get? Now it depends. Like, it really depends. When we're looking at, here's a cup of water, right? A cup of water is a cylinder. I can't remember this. But I have a cylinder, right? Cylinder. This water level is a plane. It's not like a C-section. It's when you take a baby out of a person. It's a plane and it passes through. If my cup is perfectly vertical, man, I wish I could get this better. It's a circle. But if I tilt my glass, you've all seen this, the water gets longer. Right, the water gets longer, and it's not a circle anymore. The surface of the water. Surface of the water is an oval. Right. So when we take a cross section of a shape, it depends on the orientation of the prism and the kind of shape that it's passing through. Any other physical examples sitting around here? Nope. Okay, so if we go back to our book, when we go through just kind of through a cube, we could get a square, we could get a rectangle, or we could get like a triangle, depending on which direction the prism is pointing. Okay, so this is the main thing that I'm worried about us being able to do today. When we take a cross section, when we cut something in half, when we put a plane through it, it doesn't have to be in half. When we cut it, what kind of shape are we going to get? Okay, and some of these things are really hard to draw, so I'm not going to draw them. Or I might try, but we're not going to worry about it too much. And we're just going to try and describe the shape. So for this section, this cross section for A right here, we get a hexagon, right? When we put this plane through this prism, this hexagonal prism, we get a hexagon. When we put it through this triangle, we get another triangle. For this pyramid here. When we put the plane through this cylinder, we get a rectangle. Right? Think of like if you take a cake and you cut through it, the face of the cake left is a rectangle. Just that face. The cake is still going to be circular and curved, right? This thing still has a curve here, but this space right here makes a rectangle. Okay, if we go through this cone this way, we get a circle, or if that plane was tilted, we'd get an oval. Through this sphere, we're going to get a circle. Almost everything. I think we always get a circle if we go through the sphere. Sounds right to me. Pretty sure that's true. Trying to think of a case where it wouldn't be true. And maybe if you went through it crooked. Here with F, you might get ovals with this thing sometimes, but that's a circle. That's the center. This, we're going to get a weird shape. So F here, I'm going to draw. What that would look like. This thing. And I got to refine my marker. So we have a cube, and we're putting a plane through it, and so the lines in that plane are going to look like this is the top kind of space on the plane, and then we have this, and this, and this, so we would get a trapezoid. Okay. So our goal is just like, what kind of shapes are we getting when we cut stuff? If I take a sugar cube, F, and I cut through it, what kind of shape do I get depending on which direction do I cut through it? Or E here, go back to the screen. I take a orange and I cut it in half. What kind of shapes are the sides going to be? Okay. That's the gist of this section. So it's not super complicated. Here we would get like a pentagon, right? Here we get a smaller hexagon in the base and the dimension. Okay? So we're going to sketch and describe some solids of revolution. Actually, before we move on to that, because let's just practice. Go to this screen. I would like you to, in the chat, I'm going to give you like 2 minutes. I'm going to leave these problems up here. Maybe you can see them all. Yep. I want you to figure out what that shape is. The plane passes through the thing. List them. So 3, 4, 5, and 6. What shape does it make when it passes through? Okay, so I'm going to give us about 2 minutes. I'm going to grab a drink. Okay. So 3, 4, 5, and 6. And I think how I'm going to incentivize this is, man, people were begging me, I'm going to bring the puppy on. Okay, we'll bring the puppy on stream. If we're participating, we'll bring the puppy. Or people are begging for it. You guys can figure out what you want the incentive to be, I guess, for participating. Could be the puppy. It could be someone was begging for pictures of my fridge, the inside. I don't know what that's about. That's weird. But so 3, 4, 5, and 6. They're up there right now. Tell me, what kind of cross section does that make? It's a little blurry. It might just be good. Ooh. Camera quality is super low. Stream quality is really low. I don't know why that is. Okay. That's being a pain. Yeah, we'll depending on what we get, we'll get these. Okay. So right now, if you could. Okay, so what do we got? Type it in the chat. What are the shapes? 3, 4, 5, and 6 there. There's 6 of us. We should be able to all figure out what those shapes are. Unfortunately, there's a stream delay. So it's not the fastest. Oh, I was going to do this. What are our options? Before I just go typing in the options, just probably with the integer. All scared. We want multiple lines here to create a pole. Here's the pole length. And I should go back to this screen. Here. And then in the chat, switch. Oh boy. To look professional stream, we got a picture of a trap split. So, if you click that link, type on the poll. Whoa, we got laggy. It did not like that. So I should be able to see the results. You should be able to pick what kind of shapes there are. I was like, no, we didn't sign up for this. Just interact. Okay. Got no votes yet. Struggling. Well, this is like different than the classroom where I could be like, well, just wait. So we got this so far. I don't remember our shapes looks like this. So looks like there's a square and pentagon, hexagon. We have one person. Well, okay. Well, we're gonna move on or talk about it. So here we've got square, right? Here we've got a triangle. Here we've got 1, 2, 3, 4, 5, 6, 7. Oh, this is a 7-sided shape. Set the ground. And then this is a rectangle, I think. Maybe, maybe not. Kind of looks like a rectangle though. Oh, it's probably not. Okay. So, last thing that we want to be able to do. The other thing is we can make three-dimensional shapes by rotating things. I can't run this session. So if I take a, you've seen this before. When the propeller on a plane spins really fast, it makes it look like a circle, right? If you were to look at it from the side, it looks like a rectangle. What should do? When we spin something about an axis, we can turn it from a two-dimensional shape into a three-dimensional shape. So here we're taking a rectangle, we're spinning it by this axis, and it's turning into a cylinder. If we spun it by the other axis, this way, if we spun it vertically, it'd make another cylinder, but it would be a different kind of cylinder. Okay? And so eventually we're going to get into volume and all that kind of stuff. But for now, we're just going to like, what kind of shape is it? Hey, no! Don't chew on that. See, dog? Okay. So here we spin this rectangle vertically, turn into a cylinder, right? And it would have these dimensions. This is a 9 because that's 9 and a 4 for the radius. We can find the volume and area, surface area of this. We take this triangle, we spin it, we make a cone. We spin it the other way, we make another cone. Okay. Here we've got a semicircle. This is going to make a sphere. This is going to make a cylinder. This is going to make a cone. Okay. So that's all for the chapter. The practice is going to be, because it's 1:45, I got to get ready for the next class. Practice is going to be, where do we go? Here, that's right. Page 621, and we're gonna do, okay, about the names, just 11 through 18, so not a ton of problems, less than it was before. Misha, hey, Misha, come here. Okay, and those are about, those, I'll send a reminder with them, don't mind me, just like that. Okay, so on the right side here, 11 through 18. What happens when you rotate it? What kind of shape do you get? Okay. This section is one of the easier ones this chapter, and we will. Oh, why are you freaking out? Oh, you like doing my finger text? Hey, the people want to see you. No. Okay. So on Friday, the other thing this week is we'll have another stream on Thursday. We'll probably get this on Friday. I think we're going to do a Kahoot on Thursday. So we'll see how many. There's 4 people in that Kahoot. Get off! Stop chewing my finger. All right. On Friday we're going to do a Zoom. So I'll set up a Zoom link and email it to your Fresno Unified emails. Misha, hey, no. I'll send it to your Fresno Unified emails so that you can get that invite. There will be a password you have to enter, and we'll just do 30 minutes of hanging out with video, or you can use your video too. I know some other people might already have classes at that time. That's fine. If you can't make it, you can't make it. I probably won't record that. I won't put it on. Yeah, I might. No, I won't put it on YouTube because there's some legal things with having more videos of you guys. Misha is named after a bear. There is an actor named Misha. Is it Misha? Yeah, Misha Barton is an actress. But that's fine. The dog is going to be. He's fine. Oh, okay. So that's it for today. If you have work, send it to me on Remind or my email. If you have questions, do the same thing. And I will see you guys on Thursday. Okay. And then live stream, Zoom call on Friday at 1. So, and that's it for today. Have a good Tuesday, whatever day it is.